Okay, page 10. Continuing with derivatives of trigonometric functions. Differentiate with respect to x. Okay, so here we're mixing other functions with trigonometric functions. The derivative of x squared is 2x. The derivative of cosine is negative sine of x. Okay, C. The derivative, this is a product, right? So it's not as easy as A. When you have a product, you have to say identify u is equal to e to the x, v is equal to cosine of x, u dashed is equal to e to the x also because the derivative of e to the x is just e to the x, v dashed is equal to negative sine of x. Now we're going to do the product rule. So we're going to have e to the x times v dashed, negative sine of x, times u dashed, e to the x, times v, which is cosine of x. Okay. E, natural log of sine of x. This is a function inside of a function, so we're going to use the chain rule. So we're going to first take the derivative of natural log, which is 1 over x, or in this case 1 over sine of x, because sine of x is the inside function. Then we take the derivative of the inside function, cosine of x, and we multiply it afterwards because we use a chain rule. That is equal to cosine of x over sine of x. Okay? Sine 3 of x. The derivative of sine 3 of x is a function inside of a function, so we take a derivative of the outside function, which would be cosine of 3 of x, and then we multiply times the inside function, 3x, the derivative is 3, so the answer is 3 cosine of 3x. Okay. 3 times tangent of 2x. So here, the derivative of the 3 just remains out front, right? The derivative of tangent is 1 over cosine squared, remember? So it would be 1 over cosine squared times 2x, or of 2x. And then we take the derivative of 2x, would just be 2. Okay? And then if we simplify that, it'll be 6 over cosine squared 2x. Remember, cosine squared is secant squared. 1 over cosine squared is secant squared, because secant is the inverse of cosine. So you could also write it like that. Okay, sine of x over x. So this could be treated as a quotient or a product. Let's do it as a quotient because I think we did one before where we treated it as a product. So let's do it as a quotient. So u is equal to sine of x. V, which is the denominator, is x. So u dashed is equal to cosine of x. V dashed is equal to 1. So remember the quotient rule is u dashed v minus u v dashed divided by v squared, right? Now this is on your formula sheet. You don't need to memorize that. So u dashed is cosine of x times v, which is x, minus u, which is sine of x, times v dash, which is 1, so you don't need to write anything, divided by v squared, which is x squared. So now we'll have cosine of x divided by x minus sine of x divided by x squared. Okay? Again, more derivatives. Sine of x squared is a function inside of a function. The derivative being cosine of x squared, and then you multiply times the derivative of the inside function using the chain rule. You could rewrite that as 2x cosine x squared. Whenever I have room to rewrite it, how about if I try to rewrite it so we can put the coefficients before the trigonometric functions or whatever else it is. Now here we have square root and on the outside and cosine on the inside. So this is a function inside of a function. The outside function is this is the same thing as cosine of x to the 1/2. Okay, so first we're going to use the power rule. 1/2 cosine of x to the negative 1/2, and then we use the chain rule and multiply times the derivative of the inside function. So let's rewrite this more nicely. So we'll have negative 1/2 times sine of x, and then in the denominator, we'll have square root of cosine x. Okay. Derivative of cosine cubed x. So this is a function inside of a function, the outside function being x cubed. So the derivative of x cubed is 3 cosine squared x times derivative of cosine, which is negative sine of x. Okay, and so if we want to rewrite that, negative 3 sine of x cosine squared x. Alright, now the cosine, here's a function inside of a function, cosine function inside the cosine function. So first we do the outside function, negative sine of cosine x, and then we multiply times the derivative of the inside function, which is negative sine of x. So if we simplified that, we would have positive sine of cosine x, and maybe to simplify it, we'll put sine of x in front so that it's more clear that it is sine of x times sine of cosine x. Okay, derivative of 1 over sine x. So the derivative of let's see, we could do this as using like the power rule. So this is the same thing as if we had sine of x to the negative 1. So the derivative of the outside function would be negative 1 times sine of x to the negative 2, and then we take the derivative of the inside function, which would be cosine of x. So that would simplify to negative cosine of x divided by sine squared x. Okay, and then k. 2 over sine squared of 2x. Here we have, wow, this is, yeah, so this, we can rewrite this as 2 times sine of 2x to the negative 2. So the 2 stays out front, and then we do the power rule, so the negative 2 comes out front. We put the inside function just as is, and then we raise it to the negative third power, because negative 2 is going to be reduced by 1 even further. And then we multiply times the derivative of 3x, which would be 3. So then we have 2 times negative 2 times 3. So negative 12 divided by sine cubed of 2x. Okay. Last one. Find the gradient of a tangent to part A, f of x equals sine cubed. So the first thing we're going to do is we're going to find the derivative of that. Once we find the derivative of that, then we can insert the value x equals 2 pi over 3 to see what exactly is the numerical value of the gradient instead of just the equation to find the gradient. So the derivative of sine cubed x is, use the power rule first, 3 times sine squared of x, and then you take the derivative of what's inside, which is sine of x. The derivative is cosine of x. So if you want to simplify that, you would put 3 times the cosine of x times sine squared x. Actually, the way that was written wasn't too bad. I'm going to go back and do it like that, okay? That's fine, right? Okay, now I'm going to insert x equals 2 pi over 3 into the equation. And the way I'm going to do that is I'm going to use the calculator. I guess I don't really have to use the calculator, right? Let's not use the calculator, just so that you get used to doing unit circle. So remember, 2 pi over 3 is basically 120 degrees. The reason why is 1/3 pi is 60 degrees, right? 2/3 pi is 120 degrees, okay? So this would be like 60 over here, and this would be 120 over here. Let me erase that. Okay, so what is the sine of this angle? Okay, so the sine would be, let's see, the opposite, which is the square root of 3 over 2 divided by 2. So the sine of the angle is equal to square root of 3 divided by 2. The cosine of this angle is equal to negative 1/2, because it's in the left side direction, so it would be negative 1/2. So now let's substitute in. So we're going to have 3 times sine squared, which would be square root of 3 squared, which would be 3 on top, and then 2 squared, which would be 4 on bottom, multiply times the cosine, which is negative 1/2. So that would be 3 times 3 is 9 on top, and 4 times 2 is 8 on the bottom. Negative 9/8. Okay? Now how about b? So b. The function is cosine x times sine x. So let's find the derivative of cosine x times sine x. Well, cosine times sine is a product, so we're going to use the product rule. So u is equal to cosine, v is equal to sine, u dashed is equal to negative sine, and v dashed is equal to cosine. Using the product rule, we're going to have cosine u times v dashed, which is cosine, plus u dashed, which is negative sine, times v, which is sine. And that is equal to cosine squared x minus sine squared x. So let's evaluate that at the point where x equals pi over 4. Okay, well, let's draw. Pi over 4 is 45 degrees. So we have square root of 2 to square root of 2. So these are the proportions. So the sine and the cosine are going to be equal. Both are going to be square root of 2 over 2. You can also think of it as 1 over square root of 2. Same thing. Multiply the top and the bottom each by square root of 2. You can change one to the other. Okay. Now, so let's plug this in. Cosine squared of x, once we plug in x equals pi over 4, we're going to get 1 over square root of 2 squared, and then we subtract 1 over square root of 2 squared. Hey, look, we're having the same thing minus each other, so we're going to get 0, so the value would be 0. Okay, and that is the end of page 10.